In this video, I am going to tell you about the Gaussian surface and properties of the Gaussian surface. So first, come on this topic, what is a Gaussian surface? As it is clearly written here, a Gaussian surface is a hypothetical closed surface in three dimensions through which electric or magnetic or gravitational field is to calculated here. So for Gaussian surface, first the surface should be closed, and with the help of this Gaussian surface we can calculate the electric field, magnetic field or gravitational field due to a charge or distribution of the charge at any point. And the properties of Gaussian surface is what here? First property, it should be closed surface. So first property of the Gaussian surface should be closed. Second, the surface means Gaussian surface must be passed through the point where electric field is to be calculated. Third point, the surface must have a shape according to symmetry of the source. Symmetry of the source means according to the symmetry of the source charge, either that charge is point charge or distribution of the charge. And fourth point, field, and that field here I am discussing about the electric field. The field is normal to the surface at each point and constant in magnitude. It means all these are the property of the Gaussian surface. For example, now if we consider, suppose a point charge plus q which is placed at point O, and our aim is to find electric field due to this charge plus q at point P. And suppose this point P lies at distance r from it. Suppose this distance is r. So for finding the electric field due to this charge q at point P, first we will draw a Gaussian surface. And you know, a Gaussian surface is hypothetical closed surface in three dimensions through which electric, magnetic or gravitational field is calculated. So what should be the first property of the Gaussian surface? First, it should be closed surface, and the surface must be passes through the point where electric field is to be calculated. Now, this distance point P is r from O. Here also you can take any point which is same distance r. Here also same distance r. Here also same distance r. So in the symmetry of this charge q, you can draw a surface like this one, which is closed surface. This surface is closed, and at each point on the surface, its distance from q is how much here? R. And that point means that surface is passes to the point P. So first you see here, is it fulfill all the properties of the Gaussian surface or not? First, it should be closed surface. Yes, the surface which passes to the point P is closed. The surface must pass through the point where the electric field is to be calculated. Yes, you want to calculate the electric field at point P, and that surface is also passes to the point P. The surface must have a shape according to the symmetry of the source. This one is a source charge plus q, and this surface is in the symmetry of this charge plus q, and field is normal to the surface at each point. And you know, electric line of forces when comes out from this charge plus q, suppose like this. So all these electric line of forces is normal to the surface everywhere, and the magnitude of the electric field due to this charge q at distance r everywhere on the surface is remains same. So that surface is considered as a Gaussian surface for this charge plus q, and which fulfill all the properties of the Gaussian surface. Now let us consider the another case. Suppose a wire having the charge Q is given to it, and that charge is uniformly distributed throughout its surface here. And again our aim is to find the electric field at point P due to this distribution of the charge. And for this purpose, again suppose this distance of this point P from this distribution of the charge is R. So at the same distance R also you can take this side also here, point P, P dash, and suppose this distance is also R. So for finding the electric field due to this distribution of the charge, line charge at point P, again we will draw a Gaussian surface, and that Gaussian surface should be fulfill all the properties which is here. And in this case, symmetrical to this charge, we will draw a Gaussian surface, and that Gaussian surface must be passes to the point P. That Gaussian surface must be passes to the point P, and the surface must have the shape according to the symmetry of the source. This one is a source, and in the 3D the symmetry of this one, when we draw a surface which passes through the P, then it will comes in a form of cylinder. So this one is what here? This one is a Gaussian surface. Gaussian surface for this distribution of the charge, and that Gaussian surface is passes through the point P, means the point where you want to find out the electric field, either this side or another side, at this side, in front of it is in the 3D. And for this cylinder, for this Gaussian surface, there are three surfaces here. One is this chord surface, this one chord surface, and these two are called here plane surface. And the electric line of forces or the electric field is always perpendicular to the surface, means on this Gaussian surface here. So dear student, you will go through what is the definition of the Gaussian surface and what is the property of the Gaussian surface, and also if you want, then you can write in your notes, and in the next video I will give you the application of the Gauss theorem. Thank you.